This is another video in support of the MiFID II RTS project. The project's hosted on GitHub and you can see the URL at the top of the screen there. Now this video is going to be looking at using the code that's in the project to run an SI calculation. If you look at the home page for the project, you can see that there are in the description links to a number of videos, and this is going to be one of those videos, and also to some Jupyter notebooks. We're going to be looking at the Jupyter notebook which is linked here. And as it says, this is an example of running the SI calculation using generated sample trades. In another video we looked at how to generate sample trade data from the RTS II taxonomy, and in this example we're going to be using generated data to run the SI calculation. On the GitHub website you can look at the examples, you can see the code, and you can see the results of executing the code, but you can't run the code. If you download the code to your own machine and you install and run the Jupyter notebook server, you can run the code yourself, and that's what's going on here. So with the Jupyter notebook server running, and with it pointing to the same folder that we find in here, let me just go back to the top. You see these files here, see the license and readme. Over here there's the license and readme. Okay, so we're looking at the same place but through the Jupyter notebook browser. We pop into here and there, and we're looking at exactly the same thing that we saw over here by going to that. Okay, SI calculation example. Right. So what I'm going to do here is to go through this example and show you how all the bits work. So the objective is to do this SI calculation, and we can run the code in here. So in this model we can actually execute the code as we go along. That's what I'll be doing. So first of all I'll reset everything and show you how to execute the code. If you select one of these things on the page, it's called cell, and you see there's the word in here. Right? In means this text is going to go in. So we're going to ask the Jupyter notebook to run this particular piece of Python code. So I do control and return. We can see that a number has appeared in here, number 1. This is the first thing we've executed on this page. And what this particular cell will do is to import code that we need for the next bit. The next bit is going to be to use the RTS2 code, get hold of the root of the taxonomy, select a particular asset class, in this case credit derivatives, and generate some sample trades. In this case I'd like to generate 500 of them. And here in this cell we can see we're going to print some things out. We're going to say that we've generated a count of trades, and we're going to print out the string. Here's one example, and in the next line we're actually going to print out the variables inside of one of the random trades. So without any further ado, let's run it. There we go. There's a print line, generated 500 trades, which is just what we expected because that's what we asked this thing to do. And here is an example trade coming out. Okay, so this is how the Jupyter notebook works. You go to cell, you run it, and the results are there. So if we reset this whole thing again, we'll see that the order that you run things is quite important. Notice that the numbers have all vanished. We're going to go and dive into the second cell and run it, and we get an error. We get an error because RTS2 Annex 3 is not defined. It's defined in this first cell here. So if you don't run this first cell, the second one won't work. So let's start again and do it all in the right order this time. Oops. Okay. First of all we do that one. That's number 1. Then we do this one. That's number 2. Then we do this one. Number 3. Okay. Jupyter notebook. To do the SI calculation, we need the trades. That's one of the inputs. But the trades need to be more than just able to be classified. We need some additional information for the SI calculation. I'll quickly run through this and you'll see how this matters later on for the calculation itself. So the LEI, that identifies a legal entity. Every trade will need a trade date. We run that, and here's an example of a trade date. Every trade will need a MIC. A MIC is an identifier of a venue. And we need this because we need to know if things are being traded on venue or off venue. Own account. This is whether, when the trade is done, the bank is using its own money to trade or whether it's using the client's money to trade. Client order. And we say how big is the trade in terms of euros. And the very last thing we do is to run the whole trade back through the classification thing again and get a classification for it. The random example we picked this time is a bespoke basket credit default swap. We've generated 500 trades, and we've added a number of attributes to every single trade to make it look like a sufficiently realistic trade to make the SI calculation work. Now the SI calculation is more of a set of filters. There are 3 filters, A, B and C. You can see them down here, A, B and C. All the filters basically are going to filter based on the count and the notional sums of trades which are OTC. The next thing is we're looking for trades which are done on an account, that is using the bank's money, discussed that earlier on, and in response to a client order, so the client's actually asked us to do the business. So the trades which are OTC, using the bank's money, and in response to a client order, we'll call SI trades. Other factors when we're doing the calculation are to look at the RTS2 subclass in question. We need to know, is this particular RTS2 subclass liquid or not? Liquid just means, is it freely tradable? If I decide I want to buy or sell a certain amount of a particular thing, if it's easy for me to do, then it's liquid. I can just go into the market and buy and sell. If it's hard to do, if I've got to really wait for a few days before one becomes available, then we could say that's illiquid. It's not a liquid market. Now, the determination of whether something's liquid or not is up to the regulator. The regulator has to come along with a list, and they have to tell us which of the RTS2 subclasses are liquid and which are not. And also, for every single RTS2 subclass, the regulator has to tell us how many trades have been done in the market as a whole, the whole of the market that they're interested in, and they've also got to tell us what the notional value of all trades are, because all those things are going to get used in the calculations that are just going to come up now. So, onto the SI calculation. The first test, test A, says this. It says if the subclass is liquid. Now the regulator would have told us this. Right? So if we're looking into a subclass, if it's liquid, then we say if the count of the SI trades done by our legal entity is more than 2.5% of all the trades done in the EU as a whole, right, and we've done more than 1 a week of those kinds of trades, greater than or equal to 1, then we're an SI. That's the first filter. So if it's liquid, we've done 2.5% of the market, and we've done more than 1 a week, we're an SI. If the subclass is not liquid, and we've done more than 1 a week, then we're an SI. And the third filter is if the sum of the notional for the SI trades, that is not just the number of trades, the count here, it's actually what's the value of the trade. So it's the value of all the trades that we've done, the SI trades for this LEI. And lastly we have C. If the sum of the euro notional for the SI trades, that is the SI trades done for our LEI, if the sum of the value of the trades is greater than 25% of all the trades that the LEI has done. Okay, now remember that the SI trades are a subset of all the trades that this particular bank has done. So if the SI trades are more than greater than or equal to 25% of all the trades that we've done, then we're an SI. We're also an SI if the notional of the trades we've done is more than 1% of the whole of the EU. So those are the 3 tests. Right, let's run them. Right, so the whole point of this exercise was to generate the data. We've done that. Understand the calculation. We've done that. And now let's run it. So we're going to write a little bit of code here. Again, we're going to write something in Python. We're going to introduce a few classes. I'm not going to go through this in a great deal of detail. There's a class called report. And this basically is going to produce a report that says, oh, well, this particular legal entity is an SI for so many, and here they are, and this is why they're an SI. Okay, so that's what this report is going to do. It's got calculations in here. You can add trades to the report, and you can ask the report itself. Look, it says this LEI is an SI for so many. Within the report, right, there are a number of subclasses. So each subclass is kind of looking after its own territory. It's making sure that it knows how many trades it's got. And to that end, it keeps an aggregation, so we know the SI trades, the counter trades, and so on and so forth. And each subclass actually implements this. So here's the calculation. This is the SI calculation. If it's liquid, 2.5%, 2.25%, so on and so forth, right? So all the things we discussed before, this is it. This is where the calculation happens. So if we go to an instance of that class and say, are you an SI? It will either say yes or no. and it will tell us why. The last class in here is the thing that represents the aggregations, and this just does the totting up, but it also does some synthesis of the data that we don't have. In this example, of course, the regulator isn't telling us if a particular sub-asset class is liquid or not. It's not telling us how many trades there are of a particular thing, and it's not telling us anything else it would normally tell us, right? So all that has to be generated. So having put all that code together, let's run the report. Again, did I actually compile all of that? No, right, see there's no number here, so I didn't actually compile it, so let's run that code. And now I can run the report, and there we go. So in this particular case, the LEI is an SI for 4 out of the 12 subclasses traded over the last 5 weeks. And here they are. For this subclass here, okay, and we can say that's the CDS index options sub-asset class, maturity bucket 4. We blow the notional size test. Okay, so this is too big. So we're trading more than 1% of the whole market, or one of the other tests for that. Here, that's a notional size test again. Notional size test. Notional size test. Well, that's a bit boring. So let's run it again. So the beauty of this is you can run it as many times as you like. So restart and run all. And so we can go back up and have a look at, there, this is better. 8 out of 12. So now we've got a non-liquid instrument test failed, or passed if you like, to make it an SI. Notional size test, notional size test, notional size test, liquid instrument, notional size test, liquid, that's it. Okay, so anyway, that's the report, and you can run it as many times as you like and regenerate the data just by rerunning this page. Here's another way of running the same thing though. So what we're going to do here is put the data into a tabular structure using something called pandas. So just very briefly, we build all the same data up in the tables and we run the calculation again, and here you see the results. Okay, so we've got these have basically been picked up by filter A if it's liquid and more than 2.5% and more than 1 a week. Here they are, and you can see in this case greater than or equal to 1 a week captures that and captures that, and the what's the other one? The trade count, where the trade count is 6 and the EU trade count is that, and that is more than 2.5% of that. Yeah, there you go. You got caught up in there. Here's the illiquid one. If it's not liquid and the average number of trades is here, right? Okay. So and the same here, and this is the notional test. Different ways of running the same thing. The point here is you can come along and see the code which is in the MiFID II RTS project being run. It's being run and generating a lot of trade test data, and it's also running an example of the SI calculation. Let's run it again. Restart and run all. This is interesting. Nothing on this particular run failed tests A or test B, and we've got a number of tests which run over the notional things. Let's run it again, see if we can get a more interesting mix. There we go. That's a good mix. So we've got 1 for test A for liquid things, 2 for illiquid, and several for the notional test. Back over to GitHub on the internet. Here's the code. Right, you can see all the stuff we've just been through. You can see a particular snapshotted frozen run of this. If you want to run it yourself, go to the home page, clone the repository, download it to your machine, install the Jupyter notebook system, and you'll be able to run the things that you just saw in this video. Please do watch the project, please star the project, and if you want to have a look at the code, please fork the project. Thank you very much indeed.